Hello, Professor. My name is Josh Rodriguez. My lab partner is Carlos Verdosca, and today I'll be presenting Lab 2. So as you can see here, I have my three include statements, texas.h, which is going to act as the grader, stdint.h, which is essentially going to provide us with specific int values for inputs in our finite state machine, and tm4c123gh6pm.h, which is essentially going to provide information for a systic module, which is going to act as a delay for the lab. So as you can see here, I decided to initialize port E and port B, as I believe those were the best ports for this lab. I also decided to set up the system clock here using the SYS-CTL RCG-C2R, and obviously it's set to 80 megahertz as the lab is intended. I also have several modules here, or several functions. Disable interrupts, and enable interrupts, obviously. Then I also have port E init and port B init, which initialize the ports for the lab, both of them being port E and port B. Systic init is going to initialize the system clock, which is then going to be used by systic wake and systic wait 10 milliseconds to act as delays for the lab. As you can see here, I also decided to use a finite state machine. I have the structure I decided to use was state, and it also has three values known as out, time, and next. Out representing the output of the lab. In other words, it's going to represent what the lights of the LEDs will be. Time is going to represent the time that occurs at the time for the lab, but it's also going to be used as a delay for the lab. And next 4, which is essentially going to represent the finite state machine. Since it's 4, we obviously know that there's going to be 4 states in the finite state machine. So as you can see here, I decided to define the states as go n as 0, wait n as 1, go e as 2, and wait e as 3. Obviously go n being go north, wait n being wait north, and so on and so forth. Signal and sensor both receive data from the ports. Signal receives data from port E, essentially the output, which is essentially the LEDs. So signal basically receives the output or displays the output of what the LED should look. And sensor is essentially receiving the data from the switches. So depending on the switches, it'll change how the signal is. And obviously I have right here the finite state machine, and these are the 4 states. I took this from the lecture that was provided, and it acts and it does its job as it should. Then we also have the main function here. So first we initialize using the Texas, and this activates the grader and sets the system clock to 80 millihertz. We decide to enable interrupts and initialize both all port E, port B, and the system clock. But also we decide to create values present, PS, and input. PS representing the present state machine, and the input representing what the input we received from the switches. So as you can see here, we also set the present state to GON, which is the first state, which is 0, which is as it should be. So then we enter the while loop, and then the signal then goes through the finite state machine, and depending on the present state, it receives a signal, and that signal is gonna basically display what the output should be on the LED. In other words, it's going to control what the light should be on the LED. Then afterwards, depending on the current state or the present state, the systic wait telemeters waits for a specific time, and then it proceeds to the next step. The next step is then using the input receives the sensor. In other words, the lab receives an input from the 2 switches, and depending on that, it then changes the state. It then changes the state of this finite state machine using the below statement. Obviously, depending on the input, it will change what the state is. And obviously here are my 2 final modules, which are used for port E and port B init. Obviously, as you can see here, I decided to comment both the delay and the system clock, as we're not going to be using these for this specific lab, and I thought they won't be necessary at all. I also decided to not use the pull-up resistors, as we'd obviously be using the resistors in our lab, which both of them being the 10K resistors and the other 3 being the 1K resistors. And obviously this does like normal stuff. It all disables the analog questions, it's the GPI clear bit, and so on and so forth. Now here we decided to have the free SysTick modules. The SysTick basically initializes the, or it uses the clock, which is in its current state, it's 80 megahertz. And then the SysTick wait, depending on the input from SysTick wait milliseconds, will cause a delay. So as you can see here, let's go to SysTick wait 10 milliseconds. So because we know, so then using calculations, since we wanted to get 10 milliseconds for a delay, I decided to multiply 12.5 nanoseconds with 800 and 1000. And this is the formula we would use to receive a delay, the delay we want. So in this case, we multiply this number, which in this case is 800,000, times 12.5 nanoseconds, which essentially represents the tick, to get 10 milliseconds. So then, as you can see here, we have a delay one, which is essentially gonna be 80,000. So this delay continues and continues until we reach the delay we desire. In this case, in 10 milliseconds. So as you can see here, we have a 6-tick wait, and then this input goes into here, and it keeps counting and counting and counting until it finally reaches 0. And when it does, it finally ends it. In other words, the delay is complete. So unfortunately, I tried building the lab here, but for whatever reason, it refuses to load on the screen. So as you can see here, I keep getting this error, and I'm not really sure what to do. I also was unable to provide the simulation. So as you can see here, I'm doing options for target lab 10. I go to debug and I use the simulator. And unfortunately, I was also unable to get that to work. Yeah, it's very unfortunate. The LEDs just don't seem to change at all, to my knowledge. And the lab didn't work as according to plan because for whatever reason, my computer isn't accepting, or it isn't registering the microcontroller. So this is the lab I decided to do. As you can see, all the ports are connected. PA3 and PA2 are both connected to switches, as well as the red LED being connected to as you can see here. So the red LED is being connected to it's being connected to P2, and the yellow LED is being connected to P1, and the green LED is connected to P0. And as you can see, they have all the resistors. The switches have the 10K resistors, and the free LEDs having the 1K resistors. And obviously they're attached to ground and voltage, but sadly, no matter how hard I try, it just doesn't seem to work. And that's my lab. Even with the help of my partner, I still couldn't figure out. So, thank you.